Okay, so I just hit the record button and we'll go ahead and get going. So if you look at the course website right now, it should look like this. So you'll notice up at the top, hopefully, that it says week 2 lectures. So this is the week 2 material posted in this module. Now, this is pretty similar to last week. The only difference is there is not an introduction, and I'm not linking the syllabus every week and that kind of thing. Maybe I should, but at least right now I don't have the syllabus linked here. And so in the introduction for this week, I'm just pointing out how a normal week will look basically. So you're going to find any links to files that we're going to go over. You're going to find old videos or new videos if I have them posted for you. You're going to find the assignments that are going to be Zybooks, um, homework and reading, and a lab to work on, at least one lab to work on. So we would have had 2 labs this week, actually. The only reason we're not having 2 labs this week is because Monday was a holiday for my face-to-face class. And so they only have uh, one meeting this week when they're supposed to have two. Otherwise, we would have had time for 2 labs this week because this week's lab is also very simple. So we could have squeezed 2 in. But there's only one lab for this week because of that. And you may or may not find links to older assignments in the current week. If you're ever looking for older assignments, what you want to do is use the modules link over here on the left-hand side. So if you click modules like this and scroll down, you'll be able to see all of the weeks. So right now we just have week 1 and week 2, but and obviously in the future we'll have more weeks and you'll be able to see what assignments were assigned during that week and you'll be able to see the due dates and all of that stuff. Um, I'll just click home, get back where we started. And yeah, so you're looking for older assignments. I recommend just going to the modules page. Now for live Zoom meetings, well, this is the live Zoom meeting. So we have one today on Tuesday. We'll have another one on Thursday. Um, After we have the meeting or after the meeting concludes, I'll have a file on my computer with the recording. I still have to upload that to YouTube. I can't just use the Zoom recording because, well, they're deleting a bunch of Zoom recordings soon. And I don't know if they're safe there. So we're recording on Zoom, but then I'm putting it on YouTube anyway, which is how if you check the meeting from last week, you'll see that it's a YouTube link. Anyway, so office hours are here. So Monday, Tuesday, Wednesday, I have office hours. So there's office hours today and there's office hours tomorrow. You'll have to actually click the link in order to get the Zoom link and so on. And then we get into this week's stuff. So this week's material is we're going to be talking about variables in, in Java. And yeah, that's about it. So this week, kind of the topic is variables. Probably next week too is also going to be more stuff with variables because we're just going to be getting used to learning how to do things in Java. And so you'll see that the Zoom meeting is linked in each lecture. The recording is not there yet for either lecture 1 or for lecture 2. And then below all this stuff, we have the assignments. So the week 1 assignments are from last week. These are the things that are due this week. And so I just figured I would post them there for you uh, to save you from having to go back to last week to look at them. And then we have the new assignments for this week. And you'll see that this is the basic setup. So every week there's going to be a reading. Every week there's going to be a homework. Every week there's going to be at least one lab. And if there's anything else, it'll be there. But most weeks count on reading, homework, lab, and maybe 2 labs. Um, Sometimes you'll have a discussion board assignment. And that is the setup. So having said that, I'll just point out, well, I guess I can't because I'm in the wrong class here, but the way that the lectures are generally going to be is the majority of lectures have a set of lecture slides that I wrote. However, uh, this first lecture here, I guess it's technically the second lecture, but so the second lecture here on variables, for some reason, when I was looking, I didn't have one called Lecture 2 Variables. I only had Lecture 3 Variables. Um, and I was missing the first part of it. And so the lecture slides that are posted here are not the normal format. So this lecture might be kind of, the lecture slides are not just here's a set of lecture slides that covers exactly one lecture, which is how I usually do it. So just be aware that this is just kind of an odd lecture for today, but in the future, they'll be more organized than this. Um, yeah, having said that, all that, I think we're ready to get started. So what we're going to be looking at today is just going to be the variables, and also we'll probably just jump into the Zybooks as well, so that we can look at it. So maybe I'll just click on one of the Zybooks links just to get over there. All right. Having said that, let's go ahead and get started. I'm going to actually start by looking at this middle set of lecture slides. The three things that are listed here are the extra reading section 2.2 in Java uh, notes 9 here. This is a textbook. So if you download this, downloading it somewhere, there it is, open up. This is a textbook, and this is just a free textbook. And so you might want to just download this to use it as a reference, because it covers a lot of stuff. It's like 700 pages, 800 pages almost. So a lot of what you might be wanting to look up is just in here. So that's why that's linked, the last one. The lecture slides are what we're going to look at. That's going to be kind of like a PowerPoint type presentation, although it's in PDF format. And then the top link here is just kind of a page that I just made right here in Canvas. And this is just kind of a quick summary of some of the stuff you need. So like if I click on variables for that top link, you'll see it's just a relatively short Canvas page that says some of what's in the previous lecture. Sorry, in the lecture slides. All right. So let me open up this middle link, the one that was called lecture slides. Looks like it downloaded with the name variables 11111. Um, and we'll kind of get in here. So this also kind of covers the beginning of making a Java kind of project here. Oops, I just minimized the thing. How did that happen? Okay. Um, so I'm gonna skip through the first couple slides here because we want to get a little further than we were last time. So we had this picture in the previous lecture where we had like a program running on the processor, and there's input and output typically. Um, we learned a little bit about structuring our code last time. So specifically, we learned that we used kind of these curly braces or just braces are used to organize pieces of code. Let's skip through here. Um, we also mentioned that when you start a program, whatever you put in the main method is what will run. And that's about where we stopped. Well, not really, but we did some of that. So let me get a blank project up in Eclipse. So I'm running Eclipse over here. I'm going to create just a sample project for this lecture. So I'm going to go to File, New, Java Project, and I'm going to call this lecture 2, I guess. Make sure to not check the box that says moduleinfo.java. Then in here, I'm going to right click on source, SRC, and do a new class. And I'm just going to call this again lecture 2, but I have to follow the rules for naming things here. So the rules for naming a class is that it has to start with an uppercase letter, and we can't have any spaces. So I used an underscore instead of a space. I'm going to check the box for public static void main, and we get something like this, which is a basic Java project that does nothing, essentially. So every Java program starts with a class, And inside of that class, there is a method called main, this thing highlighted green, and where the middle of this is where your code goes, right? So we put our code here. And we did talk about this last time, I believe. So we put all our code in this section. So you got to be paying attention to where the braces are, because if you try to write code here, then you're going to get an error, because right here where I am now, line 13, is after this first curly brace, which actually you'll see matches up with the curly brace up here, which is the main method, which means the main method starts here on line 4, ends here on line 11, and I'm trying to do something on line 13 that doesn't work. So you have to make sure you get your code in the right place, which is here in the middle. Now, what can we do there? Well, we can do a lot of different things. And so last time, what we learned how to do basically is just print stuff out. So if I come back over here, we learned last time to do like system.out.print. I can do print line, and I can say, hi, mom, like that. Statements in with a semicolon, we also learned last time. And we do run, run, and it should run, and it should say, hi, mom. Right? So we learned how to do that kind of thing last time. So this is a statement. Um, Specifically, this statement is a method call to the method print line. All right. Now, when we're trying to do more complicated things, though, then we're going to need variables to hold our data. So, right, we have certain values that we want to access. Maybe we need to store some numbers. Maybe we want to do some calculations, right? And we want to store the result. Maybe we have some text and we want to put that into a variable so we can retrieve it later. And so the concept in programming that deals with this data is, the concept of a variable. And so we should know that there's going to be two different types of variables. This is kind of like a test question type thing. What is a primitive type? What is a reference type variable? We're going to see mostly primitive types today, I think. But there are there's reference types and there's primitive types. We should be aware of that for now. Now, what are they? So a variable, a primitive type variable is for simple types of values that are basically ones built into the programming language. And a reference type is for more complicated things that are typically defined. They're not built into the programming language. They were defined afterwards by other people who were making something a little bit more complicated. I realize that doesn't sound super precise, but exactly what a reference type is going to be more important later on in the semester. Not quite yet. Um, so the primitive types, which, as I said, are all kind of the ones that are built in to the programming languages, are we have four different ways of storing integers. And remember, an integer is going to be kind of a whole number, positive or negative, but a whole number. There's going to be what we call floating point types. We'll see what those are for, but basically, floating point you should just think of as a decimal number, like 13 point something, right? 13 is an integer, 13 point something is a floating point decimal number. We have a character type. Characters are for like letters and symbols, but only one character or one symbol on the keyboard, right? So like an uppercase A is a character. A question mark is a character. And then we have a Boolean type, which that may be a word you've never heard before, Boolean. And that stores it can only store a true or a false value. So yes or no, true or false, 1 or 0. Lots of ways to think about that. But that's all it is. It's just two values. true or false. Here's a little bit better summary of these things, which is kind of why I was going through that quickly. So you'll see that they said there were four types that were integers. And you can see if you look at kind of value here, you see integer, 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 byte, short, int, long. And this is how much space they take up. So the reason there's more than one type of integer is because when you're writing a program, you want to use your resources efficiently, which means maybe you don't want to use a lot of storage for a small value. So if you look at the size range over here on the right-hand side, what this is showing you is that the top row, for example, the name of the type is called a byte. The thing it can store is an integer. It takes 1 byte of memory, and you can store a number between negative 128 and positive 127. So there's actually 255 possible values there. Actually, 256 possible values there because 0 is included. Um, and that's the range that you have. So you could use a byte if you knew you were only going to store a number um, between negative 128 to 127. But you could not use a byte if you wanted to store a number like 10,000, just because it doesn't fit in this range. Okay. And then if the range is not big enough, negative 128 to 127, you say, oh, I need bigger numbers. Well, then you could move up from a byte to a short. And short can store from negative 32,000 something to positive 32,000 something. Okay. And that takes 2 bytes of memory, so it takes twice as much space on the computer. Okay. Similarly, you can move up to a 4 byte integer, which is the one just called int. And that's negative 2 billion to positive 2 billion. Okay. Now, the thing about these, and then you can even move up one more and go to long, which is, again, twice as big, and it can store really big numbers. But the thing about these types here is that when you're generally writing a program in Java, you're not using bytes, shorts, ints, and longs. You're just not, okay? Um, what you normally do in Java is if you need integers, you're going to be just using ints unless you have a specific need for something else. So normally, like if I say, like I'm doing an age, I'll just use an integer. Now, do you need an integer to store the number 18? No, right? Because int can store numbers from negative 2 billion to positive 2 billion. We don't need 4 bytes just to store somebody's age. Okay. But we could use an integer to store somebody's age, and we just do because we don't want to have to keep dealing with the issue of, oh, well, this integer was in a byte, but this integer was in a short. And, how can we make sure that we can, can you add those numbers without screwing things up? What if they get too big? Like we don't want to run into issues. And so by default, you just use ints. So yeah, there is byte, short, int, long, but we're just going to use ints like 99% of the time. And then when you want to store floating point numbers, which again are decimal numbers, our choices are float and double. Uh, Other programming languages, sometimes people use float a lot, but not in Java. In Java, we use double a lot. And so in all of your code, all semester, you're going to see if somebody is typing in a decimal number, they're going to use a double. Um, so, if you're doing like pi, 3.141596, I don't know, close enough. If you're trying to put in a decimal number, you'll just use double. Could you use float? Yes, but here's what, like, there's lots of reasons not to. Here's one. If I run my code right now, you'll see it runs just fine. if I go here and I change, oops, I don't know what I just did. If I change this to float like that, you think that that would be okay, but I actually get an error and it says cannot convert from double to float. And that's because the left-hand side here is a float, but Java just assumes you're typing in doubles. So Java assumed this was a double, even though over here it wasn't a double. And so um, you'll see that it recommends that you change the type of pi to double, or you can do this. But I mean, look, in order to type in pi this way, you had to say, oh, it's a float called pi, and then you had to say, oh, it's a float called 3.1415926. We don't want to have to write this. We don't want to have to write this. And we don't want to have to do that all the time in particular. And so we'll use ints for integers and double for doubles. Okay. And that's just what we do. So that means over here, when you're looking at all these values here, byte, short, int, long, float, double, that was six. Was it? Yeah, I guess it was six things. We don't care about them mostly. We care about integer and double. That's what we care about. We'll also use characters and booleans later on, but for now, not really. Uh, so yeah, then we have characters. What are characters? As I said, a character is like a symbol on the keyboard or like a letter. So like I can do a character. I'll call it letter. I don't know. A. There's a character. And the last one was a boolean. And I don't know what to call it. I'll just say value. Oops, we not that way. True. All right. So these are really the four that we use a lot: integers, doubles, characters, and booleans. Now, in theory, we haven't even learned how to use the equal sign here, but I'm just demonstrating them anyway. All right. Here's examples of primitive types. So here, look, integers are whole numbers, including negative numbers. Floating point numbers are decimal numbers, yet you can still have a decimal number that's a whole number, right? Like 5.0 is just 5. Characters are single letters, but not just letters, also symbols like a pound sign, also like even a space. A space is a character. Booleans, they could only be true or false. Some programming languages capitalize the T and F, but not Java. All right. So as far as variables go, you want to think of them as a place to store data. Okay. And it says they are implemented as memory locations. So the idea is this. Okay. So if I come back up here, I guess I'll just leave it like this. If I print out a number, I'll say the number is colon space, and I'll do plus, and I'll just do age because I see I have a variable called age up here. Okay, so when I run this now, it says the number is 18 because that's the number that I have stored there. Okay, but basically there's a place in memory now that we've labeled age, and inside of that place we've stored the number 18, but it can change. So like if I do this line right here, the number is, and then I put age, we get 18. But I can here change it and I can say age is actually 99. Now age is 99. Well, once I make age 99, if I print it out again, the number is 18, the number is 99 because it does these in order. So if it does line 6, age is 18. When we do line 6, age is 18. When you do line 9, it prints out the 18. Then you do line 11, which changes age to 99. And then when you do line 13, it prints out 99 because we've changed the value. Also, you can do math. Age equals 44 divided by 3 plus 5 minus 2. What's that? I don't know. Print it out and find out. The number is 17. Okay. Now you do have to be a little bit careful about these. For example, let me go back up here. If you do math with integers, integers cannot be fractions. So if I have like 20 and I put 20 divided by 2 like this, well, what's 20 divided by 2? Hopefully we can all do that. 20 divided by 2 is 10, right? So you get 10. All right. What if I do 5 by 2? What's 5 divided by 2? Right? Shouldn't 5 divided by 2 be 2.5? Right? But when you run this, it's just going to be 2. And that's because an integer is a whole number only. So when you divide 5 divided by 2, you get 2.5. It just throws away the 0.5, just keeps the 2. So you have to be careful and understand how these things work if you're going to do math on them. Especially if you do things like this. What's 1/3, right? Of course, 1/3 is 0.3333, right? 1/3 is 0.3333, but we can't store that in an integer because integers only store whole numbers. So when I run this, I just get, oops, 0. I just get 0. So what if I want to store 1 point or 0.3333? Well, you can. You just got to use a double for it, right? So I'll just say num equals 1.0 divided by 3.0. And we'll just print out both of these. Like this. And you can see the second one is 0.33333, but not the first one, because the first one is an integer, which only stores whole numbers. And the second one is a double, and a double can store decimal numbers. Now, you do have to be careful. Like, you probably wonder why I wrote 1.0 divided by 3.0. And the reason I had to write 1.0 divided by 3.0 is in some ways Java's dumb. And so if I just typed this the same way I typed the line above it, double num equals 1/3 like this, I'm going to get 0. And this is very confusing to people, right? Like I use a double, I use a double so I can store decimals, right? And then I did 1 divided by 3, which is a decimal. So shouldn't 1 divided by 3 be 0.333333? No, because it the way that this works is this. It works out this side first. After this side is completely worked out, then the answer is stored in num. But when Java looks at this, right? When Java sees a 1/3, it says 1. Oh, that's an integer 1. It sees the 3, it says, oh, that's the integer 3. Whole number 3. So when you divide the whole number 1 divided by the whole number 3 with integer arithmetic, you get 0.333, but it throws away the 0.33 and just keeps 0, and the 0 gets stored in the num. Even though the number here was a double and it could store 0.333, Java will choose to do 1 divided by 3 as if they were integers. The way you tell Java to treat them as decimals no matter what is to put a decimal point in there somewhere. And even just this is enough. If you say 1.0, already it'll do it right. Or if you put the bottom as a decimal, then Java will do it right. It'll treat them as decimals. If you do them both as decimals, it will treat them as decimals. The only time you have a problem is if you type them in like this with no decimals. Java will not know that you actually mean decimal numbers there. So, um, standard practice is this: when you're dealing with doubles, just try to remember to type your numbers in like this with decimal points. All right, back here. That was kind of a digression. So we are able to store numbers in variables or other things in variables, as we've already seen. We have also seen that the value can be changed, right? We've seen that because if I go over here, if I print out num, oops, run, I deleted the first one, so we only have the num now. So the number is 0.333, but if I take the number, and what if I make the number equal the number times 50? And then I print it out again. Well, apparently 50 times 0.3333 is 16.6666. So 16 and 2/3 is what you would get. Um, Now you might be thinking, hey, didn't you just tell me to type in numbers as like this up here with point 0 if you want decimals? Yeah, I did. The thing is that you're not always going to have a problem if you don't. You're only sometimes going to have a problem if you don't. And in this case, it didn't matter. So if I put 50 or 50 times 0, it's all the same. I'll get the same exact answer. And that's because this num was already a double. So there was no way for Java to treat the calculation as an integer calculation because one of the things involved in the calculation was a decimal number. So it had to do decimal arithmetic. All right, so we saw that the value can be changed. How do you declare them? Well, we've been seeing how to declare them, right? Um, so we've seen this already. The variable's type determines what it can hold. An integer holds a whole number. A double can hold a decimal number. A character can hold a character, etc. Um, you should choose names that are helpful. So they say, count is a good variable name. Speed is a good variable name. CS, those are bad variable names because somebody will come back by later and they're not going to know what C is supposed to mean or what S is supposed to mean. So you want to make sure that your variables are meaningful in their names. Okay. It needs to be declared. And then it also needs to be initialized, which it doesn't say on this slide. So going back over here, I'll show you how this works. Let's just back this up. So let's use a double num. Okay. If you just say double num, this declares a double variable called num. Okay. Keyword there is it declares it. If then I do num equals 13 point blah, like that, that initializes the variable with a value. So before you can use num, you got to do both of these things. You have to create the variable and you have to put a number in it. Okay. You can do both of those things in one line though. So if I do double num2 equals, you know, 12.1, right? Then I declared and initialized a variable num2. All right. So you can declare on one line and then initialize on another line, or you can do both of those things together where you declare and initialize a variable on one single line. You can also use math in here, right? So I can do like this. That'd be okay. So this is all fine. I didn't print out num2. We can print out num2 to look at it. So it's 4.033. 12.1 divided by 3. All right. So declaring creates the variable in memory. Initializing it puts something into it, a value. Okay. Here's a syntax. You can declare multiple variables on the same line if you have a bunch of them to do. So like I can do double, um, let's say I was doing something and I needed variables X and Y and Z and W, right? I can do this. This declares several variables like that. They don't have values in them yet. So if I tried to print them out, right? What if I tried to print out X and then I try to print out Y? I will get an error, right? And it says the variable may not have been initialized. So I declared them up here, but I didn't put any values in them. So if you want to use them, you actually have to, do something, right? I put values in three of them, um, and everything was fine. I did not put anything into W, but I didn't use W. I didn't try to print W. So there was no error. There's only an error if you try to use the variable before you put something in it. So um, you can declare several variables and then initialize them later. Um, just putting commas between them. You'd probably have them spaced this way. Okay. Naming conventions. So we have mentioned this a number of times. Classes begin with an uppercase letter. You have to do it that way. Okay. Primitive types begin with a lowercase letter. This is not something you do. They're just telling you how it works. So if you think about the types that we've talked about, int, double, character, Boolean, there were also several others, but they all start with lowercase letters, right? Um, if you use a string or a scanner, um, those are classes actually, and classes start with uppercase letters. That's just in the name of the type. So a double, a double, a double, if I want to make a string, which we haven't, we're not learning about yet, but if I want to make a string, I could have a string called like name, and it could be my name. And you'll notice that a couple things. One thing to notice is that string starts with a capital S. It's not lowercase string. And also you'll notice that I guess it's hard because of the way that this just did this. I'm gonna try to, okay, there we go. You'll also notice that double is highlighted in like this orange color, double, double, double. Int is the same way. Int character is the same way. Um, right. And these ones that are highlighted orange like this, those were primitive types. Whereas string is highlighted blue. That's just what Eclipse is doing uh, to help you see the difference between different things. So strings are classes, and so that's an uppercase S. But the primitive types were lowercase. All right. When you're naming things, when you're naming variables, you should start with a lowercase letter. Okay. That's just convention. Technically, nothing makes you do it. Okay. So like if I back this up here, so we just have like one thing here. Let me just clear this out. Um, like, let's see, uh, number, actually like my number, right? This is the sort of thing that they would want you to do to name your variables, where you start with a lowercase letter, like lowercase m, but if you put multiple words in to make it easier to understand what the number is, then every time you go to a new word, you uppercase it. And that's what they call camel case. And it's pretty easy to read. It's also really common. A lot of programmers do this. So like if I do um, int, I can say, let's see, like speed. Actually, shouldn't be. We'll do double again. Double speed of light equals, something. Double speed of sound. Right. So this is the sort of naming that they're likely to do in Zybooks, also likely to do everywhere. This is really common. So start with lowercase letters, but then additional words, you uppercase the first letter of the word to make it readable. And again, that's called camel case. I just switched to the wrong tab. All right. Identifiers. Identifiers are names such as names of variables. These are the actual rules that you have to follow. So identifiers can have letters, they can have digits, they can have underscores, they can have dollar signs. But then when it says dollar signs have special meaning, that means don't use dollar signs. So stick to letters, digits, underscores. Okay. And the first character cannot be a digit or that will confuse Java. So you could do this like double number one. That's okay. That's allowed, right? Um, right? Number two, something like that. So it's okay to name things like this. It's okay to name things like speed of light. Uh, you'll see that that camel case thing is really common, and Zybooks is going to do it all the time. If I go over here, this is this has nothing to do with our class at all. This is the code for Llama CPP, which is an AI thing. But if I'm just looking here because I knew I had the tab open. So if I look at the code that they wrote, which, we might be making a mistake here. But if I look at the code that they write here, again, this is C++, not Java. And, this is for a big program here. Let's go switch to C++ here. Name some variables. Yeah, so if you look at how things are being named here, you'll notice that they are mostly they're using lowercase letters and they're using underscores between words. So they're not using the camel case thing that we did, but again, they didn't have to. This is also valid. And so depending on the project you're working on, if you have a job, they'll tell you exactly how to do it, and you just have to do what they tell you to do, or they'll fire you. Um, but those are two ways to do things: underscores to separate words, or capitalization to separate words. You can't use dots and you can't use asterisks. That's because those are used for other things. Uh, like back over in Eclipse here, you can see that system.out.println is how we were printing something to the screen, right? Well, that's kind of tells you that you can't make a double called system.out.println, right? That would be a problem because that would confuse Java a lot if you had something like that that looks like this, but this is not a double down here, but this is a double up here. So can't do that. Dots have meaning in Java. I keep going to the wrong page. All right. Java is case sensitive. So, if you make a mistake in capitalization, your program won't run. You got to match the capitalization everywhere. Lowercase, uppercase matters. Certain words can't be used. Like, so for example, you can't create a double called int. That is not allowed. Again, that would obviously cause problems if you made a double called int, right? Because int is supposed to mean something. So you can't do that. Same thing with other words that are just used in Java. You can't call a variable public. You can't call a variable class because public and class have meanings in Java that are already defined. Um, Equal sign is for assignment. This is important to understand because this is not actually how math works, right? Like in math, let me go to Eclipse here. In math, if you do x equals 5, right? If x equals 5, then 5 equals x, right? X equals 5, 5 equals x. Those mean the same thing in math. In programming, they don't. Because when you write something like this, x equals, and you put something over here, whatever it is, I'm going to just do a little bit of math. When you do something like this, the way that Java interprets this is the entire right-hand side is going to be evaluated, right? So you take a calculator and you do 17 plus 3, which is 20, 20 divided by 3, which is, I think, 6.66. And then the final result is going to be stored into the variable x. And that's how it works. The right side is evaluated and stored in the variable that you put on the left side. So you can't switch this around. So line 8 is good, but you cannot do this. I also uppercase this weird. So this one here, you cannot do this. This does not make sense in Java. The variable has to be on the left, okay? Has to be on the left for assignment. So that's what they're going to tell you here. Uh, Equal sign is the assignment operator, and the variable named answer is assigned a value of 42. That's what answer equals 42 means. So it's straightforward, but you need to understand it. Here's some examples of assigning things. Notice that you can use variables in the expressions. So if I have, again, keep going to the wrong thing. If I have a double x equals 5, and then I have a double y, and let's say that that one is, 17, put zeros on these just because or something. Um, and you have a double z, you can say z equals x plus y divided by y. Like this makes sense. Okay. In Java, this is perfectly okay. Um, it's just going to take the values that you had up here for x and y, 5.5 and 17, and it's going to fill them in where they go on the right-hand side. So if I try to print this, try to print z, everything should be fine here. And it says the number is 1.323, whatever. Of course, you just get whatever you get. It's 5.5 plus 17 is right here on the top, and then divided by 17. So it's just going to be a weird value. And it is a weird value. So point is you can use the variable names on the right-hand side of the equal sign, and that is okay. That's what they're doing here, for example. Which of the following can be used? This is the sort of thing you're going to have to do in Zybooks this week. So, for example, would this be okay? I think that's rate 1. Would that be an okay name for a variable? Sure. Could first player be the name of a variable? It might seem okay, but one thing I didn't mention, but it was on the slide, you can't start with a number. So that's a 1. You can't start with the number 1. That's because you'll confuse Java. Java will think that you're typing a number, but you're actually typing the name of something. So you can't do it. So you could have numbers, but the number cannot be the first character. So first player is no good. Could you have a variable called myprogram.java? No, you can't have dots in a variable name. Could you have a variable called long? No, because long is already one of those primitive types, so you're not allowed to say it. Could you have a variable called time limit? Technically, yes. Technically, yes. But we told you to start your variable names with lowercase letters. Class names start with uppercase, variables start with lowercase. So technically, you're not supposed to do this, but you can. If I go over here or here, right, this code runs, I can change these all to uppercase. And I mean, if I have to change it everywhere now, but if I do change it everywhere, it will run. So this is not an error. You don't get an error if you name your variables uppercase. You're just not really supposed to. Okay. Kind of odd, but that's just the way it is. And it's important to follow these rules because um, you want to be able to rely on the fact that if you see a lowercase letter, that it's a regular variable. And if you see an uppercase letter, that it's the name of a class. Okay. And if you don't follow those conventions, then um, your code will be confusing to yourself and to other people. Okay. Can you have a variable called number of windows? Yeah, of course. This is how they told us to do it, right? Uh, can a Java program have two different variables? My variable, uppercase V, my variable, no uppercase V. Think about it. Yeah, you can. You can have two variables because the capitalization matters. So I can have I can have a lowercase x and an uppercase x, right? Those are different. This is not an error. Everything runs. Uppercase x is 5.5, lowercase x is 3.0. It's really easy to make errors with capitalization. You will make errors with capitalization and your code won't run and you'll spend forever realizing that everything looks fine, but eventually you'll find out that you messed up the capitalization. Okay. Now, if you look at this, give a declaration of a variable called count of type int and initialize it to 0. How would you do that? So the type is int, the name is count, and the value is 0. You would do the type is int, the name is count, and the value is 0. Oops, 0. That's how you do that. Where do you declare values or variables? There's actually a lot of places you can declare variables. Um, this right here, the second statement, this is where you should do it. Just before it is used is not what people do. Okay. What people do is this at the beginning of the section um, that is enclosed in the braces. Okay. That is very standard. And I was doing that too for the most part. So if you look at what I was typing today, I know we've deleted it a million times, but notice that the structure of this is all the variables up here, all the variables are up here, and then after that, now we do stuff down here. Okay. That's the structure. Again, do you have to? No. You just have to declare your variables before you use them. So uh, as long as the X, Y, and Z were declared before I had this line, everything is fine. But you should not be going down here and going like int time equals, 10. Like you shouldn't have a variable defined down here after we're doing stuff if you can help it. And you can help it 99% of the time. So you don't do that. So you put all your variables at the top. That's the way to do it. Okay. All right. Um, this will be the last thing we do because I think we're closing in on an hour. So we're going to go over some of these next time, particularly the symbol here that's percent. Um, but there's a special way of writing things. So if I'm going to delete everything in here and just go, let's say X again, let's say 5. Okay. And let's just print out 5. So when I run this, it should print 5, I think. And it does. The number is 5.0, right? Let's change this to an integer just so we don't have the point O's. I guess it doesn't really matter. So the number is 5. Okay. Now, what if you want to add a number to it? What if you need to add 3 to it? How would you do that? Add 3 to X. How? Well, it's not just this, right? You can't just, this is not correct. If you do X equals 3, that's not going to add 3, right? That's just going to make it 3. So when I run it, the second time, it's just 3. That's not correct. So how do you add 3 to it? Well, you do it like this. This is one way. X equals X plus 3. In math, this is wrong, right? X is not equal to X plus 3. But in programming, remember the way we said this works. The entire right-hand side is evaluated first, and then the result is assigned to the variable on the left. So when you do X plus 3, the 5 is filled in for the X. So you get 5 plus 3, which is 8. And then the result 8 is going to be stored into X. So when I run this, I should get 8. And I get 8. Okay. Now, what about another way to do it? I'm going to copy this all again. I want to do it again. So the way it is going to work, of course. So I'm going to get 11 now, right? Because I added another 3. But a way to do this, there's a shorthand notation. Instead of saying X equals X plus 3, you could do this. X plus equals 3. I run it again and you get the same result. So this special notation that you've never seen before, plus equals, that would be how to add 3 to a variable. There's other versions of this too. You could subtract, I don't know, 2 from X. How would you do that? X, well, you could do it this way, X equals X minus 2, right? That'd be one way to do it. The other way, minus equals 2. So plus equals 3 would add 3 to it. Minus equals 2 would, subtract 2. What if you want to multiply by 5? How would you do that? X equals X times 5, right? That's how you would do it. So asterisk is multiply. This would do it. Or times equals, right? So you can do plus equals, minus equals, times equals. You could also do divided by equals. Um, if you want with a slash. Okay. So these are just shorthand ways of doing those operations in case you don't want to type them all out. So plus equals 5 is how you can add 5. All right, so now we are done. So the next lecture is going to cover input and output. So we'll talk in detail about using the scanner, which you've already had to use in zyBooks. So maybe you're waiting for a lecture to really understand it. But that's what's going to be in the next lecture. So the next lecture we'll talk about scanner, and also we'll do probably anything in the zyBooks up until now. Okay, so I think that's going to be it for now. So I'm going to hit stop share and we're going to end this. Like I said, next time, input, out, output.